Hi, we're Group 7 and we're presenting about DNS. I'm Alexa Dart.
I'm Philip Wilson.
I'm David Hoover.
And I'm Nick Rollins.
If you're like me when you started the project, the first question you probably have is, what is DNS? DNS, or Domain Name System, is a method used to convert user-friendly web addresses into computer-readable IP addresses. DNS works by keeping a directory of all domains and IP addresses. It then routes any domain input to the correct corresponding IP address. For example, when you visit www.mst.edu on a browser, you are actually visiting the IP address 131.151.247.20. Without DNS, the only way to access mst.edu would be by visiting https://131.151.247.20. It's kind of exhausting. In essence, DNS makes our life easier. Without DNS, we would have to keep an address book ourselves of all the IP addresses we would ever need to access. A good analogy for the DNS system is a phone book. Domain name servers can be equated to a phone book in that in a normal phone book, if you know a person's name, you can look up their phone number. DNS works similarly in that it maintains a list of domain names and IP addresses. If you know a domain name, the computer can find the IP address using DNS. Now, you may be asking, what is an IP address? An IP address, or Internet Protocol address, is a short series of 4 numbers ranging from 0 to 255. Each number is separated by a single dot. They are assigned to each computer that is connected to the internet and allows for the location of literally billions of devices across the world. IP sets the regulations for two-way communications across the internet, and without IP addresses, this would not be possible. And now to continue with the lesson on DNS, here's Alexa Dart.
Now that you know a little bit about DNS, I'm going to tell you how it is organized into hierarchical levels. This hierarchy goes from the least specific at the top to the most specific at the bottom. At the top level, or root level, there are 13 name servers, which contain name server information for all the generic top-level domains. The top-level domain, or TLD level, is a name server information for domains within that top-level domain. For example, .com or .edu are both top-level domains. The second-level domain is usually the organization. It is the center section of an address. The organization must register the domain name with a domain name register. For example, if we were going to www.folgers.com, Folgers would be the second-level domain. Finally, the subdomain is a domain that is part of a larger domain. It is typically the first part of an address. It is the subdomain of the rest of the address, meaning that it is the subdomain level splits the rest of the address so the user only views part of it. For example, east.folgers.com and west.folgers.com. In this example, both east and west are the subdomains and are part of folgers.com. In the case of the global internet, there are millions of different authorities that are responsible for their own local domain space. Each of these authorities must participate in running the DNS system. Because the DNS is set up into hierarchical levels, this results in a distributed database. Therefore, in order to hold all of the aspects of the DNS hierarchy, the namespace structure is set up into similar hierarchy. The hierarchy structure of name servers is similar because there is a root server, top-level domain name server, but instead of a subdomain, there is an authoritative name server. A key concept in DNS name resolution is that each entity maintains responsibility for a part of the namespace, and it must also arrange that to have information stored on the DNS server. So, in the hierarchy root server namespace, it is responsible for maintaining information about the DNS root server. These are the most important servers because they maintain information about the top-level domain within the root. They also have knowledge of the servers that can be used to resolve domains one level below them. The top-level domain name server holds information about the top-level domain. And finally, the authoritative name server is where the requirements to have one or more DNS servers in charge of managing information about the zone is met. These servers store information about the domains, subdomains, and objects in the zone by recording the data in special resource records that are read from DNS master list. These lists are maintained by administrators, and servers receive requests for this information and then respond accordingly.
Here's a typical scenario of what happens behind the scenes when you access the internet. When you open up a web browser, such as Chrome, Firefox, Safari, etc., you typically begin your web surfing by typing a URL into the text box at the top of the page. Once you hit enter, you will begin a sequence of events that must occur to reach the destination you are expecting to reach. First, to save time, your browser and operating system will look to determine if they already know the IP address that matches to the URL you have submitted. If the page you requested is a page you have previously visited before, it's likely that the IP address has been stored in your computer's memory or cache, thus saving time to reach your destination. However, if you are entering the URL of a page that you have never visited, your operating system is configured to submit a query to a revolving name server to find the matching IP address. At this stage, it's possible that the IP address can be found in the revolving name server cache, but the only thing that the revolving name server is expected to know is where to find the root name servers. For demonstration purposes, we'll say that the revolving name server does not have the IP address you are looking for. In the next step, the revolving name server submits a query to the root name server to find the IP address that matches to the URL you have submitted. If you have entered www.facebook.com, the root server would direct the revolving name server to the .com top-level domain server. With the help of the domain names registrar, such as GoDaddy, the .com TLD server will direct the revolving name server to the authoritative name server. The authoritative name server for your particular domain will provide the IP address to the revolving name server. The revolving name server then passes the IP address to your computer's operating system, which then passes the IP address to your web browser. Now you are able to visit the web page you requested. This entire process seems fairly complex, but it all happens faster than you can blink an eye.
DNS has some security issues. The largest issue is that of Cashay poisoning. Because having one DNS server would be extremely inefficient, your ISP has its own DNS servers that cache information from other local DNS servers. The DNS network is distributed. A DNS cache is poisoned if it contains an incorrect entry. This is done by querying a local DNS server and flooding it with fake authoritative server responses. The fake response is cached. An attacker may gain control of a local DNS server and say that www.google.com points to an IP address of his choosing. The attacker may even choose to spoof www.google.com, creating an identical version, and use this for phishing purposes. Cashay poisoning is dangerous because the URL is legitimate, but it points to an illegitimate server. The Great Firewall of China uses a form of Cashay poisoning. They redirect websites at a domain level. An ISP in the States accidentally updated their DNS servers from Chinese DNS servers, and their users found themselves unable to use Twitter or Facebook. So, how are domain names assigned? ICANN, the Internet Corporation for Assigned Names and Numbers, was originally created by the U.S. government and Department of Defense to manage the core and Internet infrastructure. It coordinates DNS and IP addresses. IANA, the Internet Assigned Numbers Authority, is the department of ICANN that currently coordinates Internet infrastructure and domain names. They are responsible for allocating blocks of IP addresses. These blocks are usually assigned to different geological areas and rarely to ISPs directly. However, there are some special cases. IBM and the Department of Defense have their own IP address space. Once blocks of IP address space are assigned, they're handled by registries. A registry is the organization that manages the mapping of domain names to IP addresses. They play a crucial part in registering a domain name, along with registrars and registrants. A registrar is an organization that handles the assignment of domain names, like GoDaddy. They work for registrars to assign and sell domain names. A registrant is the user or company who registers a domain name. Registering a domain name is simple. You choose an available domain name and link your IP address to it through your registrar. Now, how does DNS affect you? DNS is an important part of the internet today. Without DNS, you would only be able to access websites by knowing their IP address. DNS allows email and instant messaging to function. Any application that uses the internet to connect two or more hosts to share information is relying on DNS. Without DNS, we would not have the internet as we know it.